Hello, this is Brandon McKinney, and this is Test 3, Part 1 for MAT 203. And here I'm going to show you how to solve this system of equations by the substitution method. So for our first equation, we have 2x plus y equals 4. And then for our second equation, we have y equals x minus 2. So what I'm going to do first is, since we already have that y equals x minus 2, I'm just going to plug x minus 2 into all of the y's. So here we would remove this y and then plug in the x minus 2. So I'm just going to move this out of the way for a second. And then in order to solve this equation, you need to add 2 to both sides, so these will cancel, and then you get 3x equals 6, and as you can see here, each x would get 2, so that means x is just going to equal 2. So we've got our x. So now what I'm going to do is I'm going to plug our x into our original y equals x minus 2, and since x equaled 2, we would plug in 2 right here, so we would get, those would cancel, so we would get y equals 0, and then to solve this, you just plug in your x and your y that you found into one of the original equations to see if it's true or not. So since we're going to do the easy one, so since our y was 0, we're just going to take that away, and then we have x was 2, and then minus 2. That would also equal 0, so now we have 0 equals 0, so that shows that these two, that our solutions were correct. So we have x equals 2 and y equals 0 for that system of equations. So now we're going to solve one using the elimination method. And to start off, we have negative 3x plus y equals negative 5, okay. And then we have 4x, try to fit all these in the screen, plus y equals 2. So here, we don't have any y equals or x equals, so we're going to use the elimination method. So what we're going to do first is, in order to cancel one of the variables out, I'm going to multiply this top equation by negative 1, and then that's going to give us 3x minus y equals positive 5. And then now you have two variables that you can cancel out. So if you just add these two equations straight across, you would get the y's to cancel, and you would get 7x equals 7. So if you divide this evenly out, each x would get one of these, so that means that x is just going to equal 1. So now what we're going to do is we're going to plug in our x into our original 4x plus y equals 2 equation. So we're going to have 4x plus y equals 2. So now we're going to plug in, since x equals 1, we're going to put a 1 in for each of our x's. So we're going to take these out, and we're just going to put in 4 1s. And from here, in order to get the y by itself, you need to subtract those over to that side. So in order to cancel out the positive 4, we're going to need a negative 4 on each side. So there's that, and then these would cancel, and then 2 of these would cancel. So now we're going to have y equals negative 2. And then to see if these solutions are correct or not, you just plug them back into one of the original equations. So what we're going to do is we're going to plug it back into 4x plus y equals 2. So there's 4x plus y equals 2. Since our x equals 1, we just plug in 1 for all of our x's. So there's 4 x's. So we need 4 1s. And our y equals negative 2. So we need 2 of these. So now we have that 2 of these would cancel out, and we have 2 equals 2. So since that is correct, then our solutions of x equals 1 and y equals negative 2 fit this system of equations, and that would be our answer. So thanks.